Okay, so what's going to happen in these sections of material is that we have sections 3.1 and 3.2 that are both about addition and subtraction. And then we're going to have sections 3.3 and 3.4 that are both about multiplication and division. Okay? We're going to have very parallel kind of feeling to these sections. Section 1 was all about sort of the concept behind addition, right? Right? How and subtraction. What is it that creates these problems? In fact, I didn't say it, although I should have before. Part of the reason why we look at these different models is because if you're always seeing students being able to subtract correctly, but there's these certain kinds of problems that they're not, if you can identify, hey, it's always a comparison problem that they're having difficulty with, then you can actually know how to help them better. Whereas if you're just looking at, they can sometimes subtract 7 minus 3, and sometimes when they give a 7 minus 3 problem, they don't understand that that's subtraction, then you can actually identify what's wrong. Okay, so that's the idea of section 1 about addition and subtraction, and section 3 about multiplication and division. This idea of being able to identify how a problem is used and what maybe a student would misunderstand when they were given a problem they were supposed to do addition and they always do subtraction in that case or something like that. Section 2 and section 4 are all about algorithms. Okay? Algorithms mean the way we do something, the process by which we do it. Okay? And contrary to what you think you might know, there are multiple ways of doing addition, subtraction, multiplication, and division. And some of your students are going to really like something that you may not really like. And some of the books that you teach them may teach it in a way that is really not comfortable for you. I'd much rather you encounter most, if not all, of the different ways of thinking about the different, different methods here than when you're teaching for the first year, wouldn't you? Yes. So that's kind of the goal of sections 2 and 4. So section number 2, we're going to talk about the concrete model first. Oh, I didn't pull the right one. There it is. All right, so the concrete model for addition looks a lot like the base 10 blocks that we talked about in the last chapter. I think it was in chapter 2. So if we were dealing with 34, we can talk about taking a long. So that's 30 because it's 3 longs, and then an additional 4. And then I can take my 18, which is 1 long, and an additional 8. And I can add these two groups of things together, combine them, into one giant sort of picture of what's going on. This is very concrete, right? Like you could actually have stacked up blocks sitting there, and the students could actually put them together when they're very done, okay? So you can count the number of longs. How many longs do I have? 4 at the moment. So I can draw 4 longs. They look terrible, I'm sorry, but they are there. And then how many single little bitty squares, units, do I have? There's 14, but I'm not going to draw 14 of those guys. What am I going to do? I'm going to make a 10 out of 10 of them, so I'm going to make a long out of 10 of them, and then I'm going to have 4 more to draw. Oh, were there only 12? Okay, that's all right. So 2 more is what I'll draw. Yeah? Okay, good. And we can look at this and we can say how many did I end up with? 42. Like 52, right? 52. All right. My screen's all messing up. I think I need to calibrate it just a sec. Okay. So, I mean, obviously I don't want to draw these pictures out forever, but they're a really good place to start. Agree? You can physically see how you would click blocks together and make it into a long and all that good stuff. Legos, fabulous, right? We can use Legos for something like this. All right, there are a couple others though that we're going to keep working through. Expanded algorithm and standard algorithm. Now, standard algorithm is the one you know, but I want to show you why you know it works based on the expanded algorithm. And there are 2 ways to do the expanded algorithm. All right, so one way to do the expanded algorithm, again, 34 and 18, just like on the previous slide, is to think of 34 as 30 plus 4. This is a little bit of a modified version of what your book is doing, but I'm going to give that to you. 30 plus 4. And then I've got 18. Well, 18 is actually 10 plus 8. Right? All right, so then we can add them together, and on our first addition, it's perfectly fine that I'm going to end up with, on the right-hand side, 4 plus 8 is 12. So I'm going to write 12 down, it's okay. I promise I'm not going to leave it there. 30 plus 10 is 40. But then we're going to take one step beyond that, and we're actually going to write the 12 out as what it really is in expanded form. So I've still got my 40. What's the 12? 10 and 2. And then I'm able to combine the 40 and the 10 together, and that is 50. And then 50 plus 2 would be 52. Sorry, I normally wouldn't write it beside there, but that's space. There we go. Another way that you'll sometimes see this expanded form written is like this. So the first time we're going to add, and it doesn't even matter whether you move left or right with this. So just for fun, let me start on the left-hand side so I can promise you it won't matter. This one we're going to start right here. So we're going to add 30 plus 10 because that's what the 3 in that placeholder means. It means 30. And that 1 in the placeholder on the bottom means 10. So what is 30 plus 10? 40. Excited to be here. Oh, goodness. And then I can do the 4 and the 8. Again, it wouldn't have mattered. I could have done them in the other order. What is 4 plus 8? 12. And then we're actually going to just write these out. So 40 plus 12 is going to be 52. So this is another way of doing expanded form. It doesn't really matter to me which way you do things on your paper, but just notice that your book's going to present a variety of items like this. The standard algorithm is the one that you probably grew up learning. It matters in the standard algorithm that you start on the right-hand side. That's an important feature, first of all. So I start on the right-hand side and I do 4 plus 8, and I would have the number 12. But it is inappropriate to write the 1 next to the 2, right? We carry it. Why? Because the 1 in the number 12 actually is 10, right? It means 10. So I can carry that 1 over to the 10s column. That's what I'm really doing, right? I'm actually moving it over now. I've moved 10 of them over into the column, so there's 1 over there. And then I can do 1 plus 3 plus 1, which is 5. Okay? I think I'm going to stop there. We could go on a couple more, but I think we'll pause there for today. There's a couple more, 3 more maybe. 3 more algorithms for addition that we will do next time.